Hey everybody, just Miss Sullivan again, and you're watching the second part of fractions, decimals and percentages. This is where we're actually going to start to use percentages in context. But just a quick little reminder before we begin. Fraction to percent, convert a fraction to a percent, I times by 100. If I want to convert a percent to a fraction, I'm going to divide by 100. So let's have a little look at 5/16. So I'm going to convert 5/16 to a percent. I'm going to times that by 100 over the invisible 1. That's going to equal 500 over 16, which is the same as saying 16 into 500. And now we're just going to have a little bit of a super quick long division practice. 16 into 50, because I can't do 16 into 5, so 16 into 50. That goes 3 times. 3 times 16 is 48. 50 minus 48 gives me my remainder of 2. Then I'm going to bring down this 0. 16 into 20. That goes once. Already I can see that I'm going to need to attach my remainders to stuff. So I need my decimals. 1 times 16, 16, 20 minus 16, leaves me with 4, and I'm going to bring down this 0. 16 into 40. 16 into 40 goes twice. 2 times 16 is 32. 40, I'll just put that little there. 40 minus 32, 8. I need my next 0. It's going to come down. So I've added a tenth, I've added a hundredth. 16 into 80 goes 5 times, and finally I can stop. Excellent, no remainders, because 5 times 16 equals 80. Brilliant. So 5/16 equals 31.25%. Excellent. Let's have a look now at converting percentage to fractions, a percent to a fraction. This time I'm going to divide by 100. So let's just go with 58%. So 58%. I can turn that into a fraction immediately. It's 58 over 100. And I can see that 58 over 100, I can simplify this. They're both even numbers. I'll just start by dividing them by 2. 58 divided by 2 is 29, and 100 divided by 2 is 50. There's not a lot I can do from here. So 58% is 29/50ths. Excellent. So fraction to percent times by 100, percent to fraction, divide, basically divide by 100. All right, quick little reminder, decimal to percent, again, times by 100, percent to decimal, divide by 100. This one's mega fast. 0.37 times 100 is going to give me the percentage. Boom, boom. Moved it 2 times. It's 37%, because that's how you multiply by 100. If I've got 89%, and I'm going to divide that by 100, basically I'm just moving it back this way 2 places. That's how I divide. Multiply by 100, divide by 100, and I get 0.89. Let's see if logically that makes sense. 89% is less than, if 100% is a whole, then 89% needs to be less than a whole. That's less than 1 whole. Brilliant. Excellent. That is 37 over 100, 37 hundredths, 37%. Yep, logically that makes sense. So now we're going to start using this in context we'll begin with finding the percent of an amount. So this is really where things come into play. And again, thinking money, this is obviously where we see this the most in our day-to-day lives. So 30% of 120. What I'm asking for here is I want to chop 120 up into 100 little pieces, and then I only want 30 of them. So I want to find out 120 divided by 100 multiplied by 30. And I know I've got a little invisible one here. So I'm going to start by just doing this straight across. I can see that 100, these guys have a common factor of 20. 20 goes into 120 6 times. 20 goes into 100 5 times, times 30 over 1. If I do this straight across, I end up with 6 lots of 30s are 180 over 5. 180 divided by 5 is 5 into 180. 5 into 18 goes 3 times, that's 15, remainder 3. And 5 into 30 goes 6 times. So it's 36. 30% of 120 is 36. I nearly wrote 36%, but it's just plain old 36. Another way I can do this, don't forget I can cancel out. So 5 goes into 5 once, and 5 goes into 30 6 times, and 6 times 6 is also 36. So that's a quick way to do it too. Let's do one more of those. Let's look for, sorry about that, 45% of 680. So again, what does this mean? I am chopping 680 up into 100 little bits. I'm dividing 680 by 100. And then I want 45 of them. So 680 divided by 100 times 45 over its invisible 1. Make sense? Excellent. So I can see here already that obviously these guys are going to have a common factor. Sorry, I'm just having a quick look. I'm going to cheat for 2 seconds because I'm a bit tired. And I'm going to go for 680 divided by 100 is 34 over 5. Excellent. 34 over 5 times 45 over 1. I could do this straight across. It is a little chance for us to revisit multiplying large numbers. So let's just quickly do that over here. 34 times 45. Excellent. 5 times 4 is 20. Carry the 2. 5 times 3 is 15, 16, 17. Now it's time for it to multiply by 40. So I start with my 0. 4 times 4 is 16. I don't want you anymore. I want you to be a 1. And 4 times 3 is 12 plus 1. So I crossed it out so I didn't get confused. 4 times 3 is 12 plus 1 is 13. Let's add these guys up. 0 and 0 is 0. 7 and 6 is 13. 1, 2, 3, 4, 5, and 1. So that equals 1,530 over 5. We'll do our quick little division over here. 5 into 1,530. 5 into 15 goes 3 times. 5 into 3 doesn't go. But 5 into 30 goes 6 times. A much easier way of doing that would be the little cancelling out again. Cancelling out diagonally. So 5 goes into 5 once. 5 goes into 45 9 times. And 34 times 9 equals 306. Let's just quickly check that 34 times 9 equals 306. So you could also have done it that way. So when I'm finding the percent of an amount, so here's my amount and here's my amount. I wanted to chop my total amount, chop it into 100 little bits. So divide it by 100 and then multiply it by the number of little pieces I want. So first I divide by 100 and then I multiply by the number of little pieces I want. This time 45% of 680. I divided 680 into 100 little pieces and I multiplied those, my answer, by 45. Excellent. That's finding the percent of an amount. The next thing we need to do is expressing an amount as a percentage. So 75 as a percentage of 450. So in order to do this, we need to, you take your little number. So this is the bit I want to find. This is my percentage of my total number. So I divide, what is 75 divided by 450? So 70 divided by 450 times 100, because I'm finding a percent. So I turned it into a fraction, 75 divided by 450, and now I'm putting it into the form of a percent. So we'll just work across this way, 7,500 divided by 450. I can get rid of this, I can get rid of this, and this time I'm going to cheat so that the video doesn't go for too long, and I'm going to go 750 divided by 45. Excellent. 16 2/3. I was going to use this as an opportunity to do another little long division activity, but it would have taken too long. Can I encourage you to try doing this using long division? So 45 into 750, just so you get some practice. I end up with 16.6 repeater. Now that's not what I do in when I'm expressing things as percentages. Usually I round to 2 decimal places. So I know that that looks like 16.6666. So if I want 2 decimal places, I want it to stop here. So I look at the number on the right, just the one directly next to it. It's above 5, so the 6 is rounded up. 16.67%. With percentages, we don't generally ever go past 2 decimal places. Excellent. Now let's have a little look. So 75 as a percentage of 450. That sounds a bit wacky. Unless I said something like, so it becomes really useful in context. What if 75 kids, so 450 is the number of students in year 8. Number of students in year 8. And 75% of you got 5 A's on your report card. 5 A's on report card. And I wanted to know what percentage of the cohort got 5 A's on their report card. It's 16.67% of your cohort got 5 A's on their report card. That's kind of cool. So percentages are super helpful in context. It always makes a little bit more sense in context. You can see that we use that all the time. Let's do another little problem. If I've got 14 girls in the class, so there are 14 girls and there are 16 boys. And this is in one class. And I want to know what percentage of that class are girls. So first I need to go, oh, hang on a second, how many kids do I have in total? So I've got 14 plus 16. 6 and 4 is 10, 1, 2, 3, 30. So I want to know what percentage of the class is girls. So there's my total number that I'm dealing with. So what is 14 divided by the total times 100. This time we might actually do a little bit of long division. So I end up with 140 divided by 30. So 30, actually I'll just quickly cancel them out there because that makes it easier. And go 3 and timesing that by 100, I've made a mistake back here. I've only added 1 0 instead of 2. So I only times that by 10. I needed to times that by 100. So 1,400. So I can cancel out just those last zeros. So it's 3 into 140. So this might get a bit squeezy, but 3 into 14 goes 4 times. 4 3s are 12. 14 minus 12 leaves 2. I'm going to pop this down here, 20. 3 into 20 goes 6 times. 6 times 3 is 18. 20 minus 18 leaves 2. So I need my little 0. Pop my decimal point in there. Bring you down. 3 into 20 goes 6 times. 6 times 3 is 18. Oh, leaves me with 2. Are you seeing a pattern here? Pop on another 0 and bring that 0 down. 3 into 20 goes 6 times. 6 times 3 is 18. I'm going to be left with 2. Oh, it's 46.6 repeating. You and I know that that means 46 and 2/3. So if I've got 46.6666666, I'm going to do what I did here and round up that last digit. And I'm going to end up with, what percent of the class are girls? 46.67%. Let's just check that. 14 of my 30 students times 100 equals 46 and 46.67, because we round to 2 decimal places when we're dealing with percentage. Cool. So you can see in context, we actually do use percentage a lot. So this is something that working out the percent of one number as a percent of another. So you put the total, you divide this one, the amount you're trying to find, by the total. So this is going to help us when we look at things like percentage increases and decreases. So this hideous picture here is, let's call it an overpriced football jersey. It was $250. It's now $200. So first I've got to work out the difference between the two. So 250 minus 200. How much has this shirt been reduced by? It's been reduced by $50. Okay, so reduced by $50, I need to work out what percent, so 50 as a percent of my original amount. Here's my total, 250. So just like I did in the last question, 50 divided by 250 times 100. So I'm just going to cheat. 50 over 250 multiplied by 100 equals, it's been decreased by 20%. Let's have a look at this one. This one's going the other way. A 12-month Xbox subscription, I don't know what they do cost, but it used to be $130 and now it's $169. And I'm trying to work out how much has the price increased. So this time I'm going to go 169 minus 130. Okay, 0 from 9 is 9, 3 from 6 is 3, 1 from 1 is 0. Okay, it's increased by $39. So this time I want to find out what percent is 39 of the original price. So that's the total I'm interested in. So 39 divided by the original price times 100, we know about our invisible 1, is going to give me 39 divided by, sorry, it was 130, times 100 is 30%. So just say that was true. My 12-month Xbox subscription has increased by 30%. So if I'm working out a percentage increase or decrease, I've got to work out the difference in price first, First, I work out the difference in price, and then I have to work out what is this difference as a percentage of the original cost. So 39 as a percentage of 130, 50 as a percentage of 250. Please email me if you have any issues with homework questions, and I will get back to you as fast as possible. Yeah, that's it for percentages.